Hello, welcome back. We're doing Chapter 3, Section 4. We're going to do another linear programming problem in this video. And as always, for this section, I'm going to do the entire problem from start to finish. And I know these videos get long, so feel free to pause it, take a break, do whatever you need to. Let's get started. So Brad's an organizer at the Boulder, see how cute they are, 10K race. And they have to hire workers to prepare the race packets. Okay? And this is going to be for one day. There's going to be a question about hours versus days. Don't worry about that. Okay? We'll address it as we get to it. All right? Now, what do they mean by preparing race packets? I don't know if any of you have ever done like a community fun run or any of the other type of organized runs that they have. For the last, I don't know, 4, 5, 6 years or so, maybe 6 years, me and my kids have done the Monster Dash. And it was actually this, I'm recording this in the year 2020. We didn't do it this year, but it did take place. I did see them running along River Road. But it's been one of the things that's been kind of fun. But in order to sign up for that, I'm sorry, not in order to sign up for it, after you sign up for it, you have to go and get your packet. It has your jacket, your Monster Dash jacket. It has your number that you pin onto your, for that case, costume, and some other information, some other stuff that you get. Okay? So in order to prepare for these big races, they have to actually hire people to put these packets together for the runners. All right, so that's the context of the problem. Let's get down to what Brad's issue is here. He needs to hire some people to make these packets. He has some people who've done it for him in the past. These, we're going to call them skilled workers or experienced workers, the ones who know what they're doing. He can just basically say, here's the material, put the packet. They don't have to be supervised. However, because they've done it before, they're going to cost $60 to work for this day. And he can hire students who have no experience, but they're going to cost $40 a day. But they're going to the reason why they don't make as much money is because they're probably going to need some supervision, right? They're going to be asking questions like, well, what do I do? So that's okay. That's what happens when you get new people into it. Now, Brad does have a budget. He can spend no more than $1,440. So we're going to get to that as a constraint. This is a constraint. He's constrained by how much money he can spend on this. So that's going to be a combination of how much he pays for his skilled workers and how much he pays for his students. We'll get to that when we get to the next page. Now, he needs at least one skilled worker for every 3 students. That kind of implies that he's going to put them in like little groups. So he'll have a skilled worker. So maybe the reason why the experienced worker makes more money is because they're also doing some supervision. So they're making sure that all the students, whether they're a high school student or high school or college, that doesn't really matter. But probably there may be some other extra duties involved there. That's why they get paid more. So there's going to have to be some sort of supervision. So he says he needs one skilled worker for every 3 students. Now, that does not mean exactly 1 for 3 or 2 for 6 or 3 for 9. If he can hire more skilled workers, that's better. So that's where the inequality is going to be in. And again, we'll get to that when we get to the constraints. He does have another constraint. He's only got 16 of the experienced skilled workers even available. So he can go up to 16, but not over 16. Now that doesn't mean he's going to hire all 16 of them. He just knows that only 16 of them are available. So when we work this problem out, we're going to try to find the combination of how many skilled workers and how many students he should get in order to make the most packets. Turns out that the skilled workers can make 25 per hour and the students can make 18 per hour based upon his past doing this in the past. Okay? So our goal here is to find out how many type of worker he should get to maximize how many packets he's going to produce. First step, we're going to define the variables. Start with the word let. As always, I'm going to use X and Y. There's nothing wrong with using some other letter for skilled workers and some other letter for students. Probably you don't want to use S for both of them, okay? But since we're probably going to be graphing this with technology, we want to use the X and Y. So I'm going to let X represent the number of skilled workers that he's going to hire, and I'm going to let y represent the number of students, one more time, that he hires. All right, let's get to the constraints. He has a constraint for the budget. He only has $1,440 to spend in this part of it. He probably has other things that he has to pay for. There's probably permits, there's probably some fees, there's probably some other material costs. If it's anything like the Monster Dash, they have to rent all kinds of equipment. It's probably like there's a lot of things under his budget. So you may be thinking like $1,440 is not that much money, but it's probably just one small part. It's only the budget for this part. So let's look at this. Skilled workers cost $60 for a day. That is 60, move this here, multiplied by how many skilled workers that he's going to have. The students are going to cost $40 each day. That's 40 multiplied by the number of students he's going to hire. Add those two costs together, and it has to be equal to or under 1,440. So that's my first constraint. He's constrained by the budget. Now the second constraint, I know I'm switching between papers here. The second constraint is this. He needs one skilled worker for every 3 students. So if I take the number of skilled workers that I have and multiply that by 3, that will tell me how many students I can have. All right? So 1 times 3 is going to give me 3. Okay, that makes sense. Or 2 times 3 is going to give me 6. Or I could have more skilled workers. So if it was equal, I would have y is going to be equal to 3 times the number of students is going to be 3 times the number of skilled workers. So again, think of it this way, okay? If this is skilled and if this is unskilled, 1 skilled worker is going to give 3 students, 2 is going to give 6, 3 is going to give 9, 4 is going to give 12, etc. Okay? So that's if it's equal. However, we do say that it would be okay to have more skilled workers. So the number of students could actually be less than the number of skilled workers that I have. All right? So I get y is less than or equal to 3 times x. Could be equal to it, but if the number of students is less than, like I can have one. It's easier if I show you. I could have 1 skilled worker, I could have 3, or I could have 2 or 1 students. I could have 2 skilled workers, I could have 6, 5, 4, 3, 2, 1 students. All right, so it could, the y over here could be less than this. The last constraint is how many skilled workers are actually available. It says they only have 16. So that tells me that the number of skilled workers is going to be less than or equal to 16. Now, why is it less than? Because we don't know if he needs to hire all 16. Remember, they're expensive. They're $20 more. So even though 16 of them are available, that doesn't necessarily mean he wants to hire all 16. He could hire less. There are 2 other constraints that are not explicit in the problem. It comes from the fact that you cannot have a negative number of people. So x has to be greater than or equal to 0, y has to be greater than or equal to 0. And the equal 0 simply means that maybe you don't want to hire, you could hire all skilled and no students. Maybe that's an option if that's going to produce the most packets. All right, so I have my constraints. Now I'm going to graph them right here. I'm going to graph my boundary line. I don't have any space to write it here or anything, and I don't want to confuse people when I take the picture. But my boundary line is going to be 60x plus 40y is less than or equal to 1,440. If I let x equal 0, I'm going to take that 1440 and divide it by 40, and I get 36. Here's 36. Here's 30, 32, 34, 36 right there. If I let y equal 0, I get 24. So here's 20, 22, 24. What that means, I'm using the intercept method to graph this in standard form. And I'll talk about the shading after I draw the line, okay? But what that means is it's possible, without looking at the other constraints, okay? It's possible under just the budget to hire no, which would be 0 experienced workers and 36 students. That would keep them under budget. And we know that that's not going to work with this constraint. So it's probably not going to be up here. But if, like I said, I'm ignoring these other constraints just to illustrate how this works. Right here, this means if you hire 24 skilled workers, you're going to be under budget or exactly at 1440, but you're not going to have any students working, okay? And we don't know if that's going to maximize anything, okay? Plus, that violates this constraint. I cannot hire 24 because I don't have 24. I've only got up to 16. All right, so that's just looking at, grab my ruler here. That's just looking at one of the constraints. I have to compare all of the constraints. That's why I was talking about it, because it's not just one constraint at a time. And of course, I'm not going to go below 0 here, go to the left of 0 here. And this is going to be below that budget. So I'm just going to put little marks here to tell me that eventually I'm going to shade below this. All right, cool. The next one, my boundary line is y equals 3x. All right, so the y-intercept would be 0, and then 3. My scale here goes by 2s. So if you want to count them off by 3, that's fine. But I can actually, I'm going to count 3 squares. So I'm going to go 1, 2, 3, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1. I think I've got enough there. I'm going to draw my line. And in this case, I'm using the slope intercept method. So I was able to graph by starting with the y-intercept, and then use the slope. So my slope is 3. And this is going to be below that line, so it's going to be below here. So I said earlier that that's not going to make sense because I'm going to end up with all students, and I can't do that. Okay, I have to have this. So that knocked that out. So now I've got this triangle shape. I've got one more constraint. This constraint, the boundary line is x equals 16. That's a vertical line. Here's 10, 12, 14, 16. That's a vertical line right here. And I'm going to be to the left of that vertical line because I cannot have an x value more than 16. So, and also, I didn't have to worry about this boundary line, but I do have to worry about this boundary line. This is my y is greater than 0, and I have to be above that because I can't have a negative number of students. So it looks like my feasible region is right here. All right, cool. So what are my vertices? Well, one of my vertices is 0, 0. 0, 0 is going to meet all of these requirements. It's probably not what I want because that means I'm not going to make any packets, all right, if I don't hire anyone. So, but 0, 0 might be useful if I was doing a different problem where I was going to minimize something. A lot of these problems are maximized, but there could be problems where there's something that you're producing that you don't want and you want to minimize it. So that's how we're going to test all of them. This one is obvious. I know that it's at x equals 16, and I know that it's at y equals 0. So 16, 0. That's if I hire 16, all 16 skilled workers, and I don't hire any students. That's going to keep me under budget. It's going to keep this ratio work. Everything's going to be fine. Okay, it's going to keep that ratio. All right? But it may not produce enough packets. I don't know. This point right here I'm going to have to try to figure out about my graph. I know that my x value is 16, but my y value looks over here, looks like it's going to be 12. Since I'm guessing this one, I'm going to put a question mark next to that because I don't know if that's accurate. It looks like it's pretty accurate, but I don't know. And this last one, where these two lines with that are, you know, where I've got horizontal or vertical lines, those are going to be easy to figure out. Okay, it's when I have lines that are not horizontal or not vertical, where the slope does not equal 0 or is undefined, where I'm going to have a hard time figuring out, did I graph it correctly? It looks like my x appears to be 8. So I think that this is 8. And it looks like my y, 20, 22, 24, is 24. But again, I'm going to put a question mark next to that because I can't just go by what it looks like. I need to make sure that I have it. Which leads me to the next step. I have to check using substitution or elimination. So, this one's going to be easy. I'm going to do it. I'm going to do this one first. What are my boundary lines? So the boundary line for this one is y equals 3x. My boundary line for this one is 6x plus 40y equals 1440. I'm looking specifically at the boundary lines. So 6x plus 60. I'm so sorry. Mea culpa. 60x plus 40y, my boundary line, that's why it's equal, 1440. And the other one is going to be y equals 3x. All right, I'll come back to the other one in a second. I don't know, which one do you think I should use? I think I'm going to use substitution. So I'm going to take this 3x and I'm going to put it right here. So I get 60x plus 40 times 3x equals 1,440. Let's do a little simplifying. Add these two together. And let's do some dividing. So I get 1440 divided by 180. It looks like I got x equals 8. And then I come back, I do y equals 3 times 8. So y equals 24. And what did I think it was? 824. My substitution proves that I have it correct. So this does give me 324. Now the other one I should check is this one because I'm not sure about that one. But this one's going to be a little bit easier to do. I get x equals 16. And again, I have this boundary line, this one going right here. So I've got 60x plus 40y equals 1440. I'm going to put that 16 right here. 60 times 16 plus 40y. It should be 96. So 60 times 16. 960, sorry I didn't put the 0 at the end, but I did 6 times 16. 960 plus 40y. 1440 subtract 960. Divide by 40, and that one I can do in my head. I get y equals 12. So what do we think it was? 1612? That is correct. So I've used substitution to prove that the points that I had to kind of guess at, I had the correct guess. All right, everything's cool so far. Now we go into our objective function. What was the whole point of doing this? Well, we find out that skilled workers can make 25 packets each hour. So that's going to be 25 times the number of skilled workers that you hire. So 1 would be 25, 2 would be 50, 3 would be 75, 4 would be 100, you get it, okay? Students can prepare 18 packets per hour. This is going to give me my total packets. And actually, I'm sorry, it says profit here because of all the other problems I was doing. It means number of packets. because this problem we're not doing money. So here's my table that I'm going to make. Number of skilled workers, number of students, and my number of packets for that many students and that many skilled workers. So I have 0, 0, 16, 0, 0, 0, 16, 0, 16, 12, and 8, 24. So for these problems, even though they seem really complicated, it actually breaks down to where it's a little obvious at the end, or sorry, some things are obvious at the end. It's obvious that if I don't hire anyone, I'm not going to make any packets. So 25 times 0 plus 18 times 0 equals 0 packets. It also seems kind of obvious that if I can hire all 16 skilled workers but no students, that I'm going to get more packets if I can hire all 16 and hire 12 students. Because again, this will be under budget. But let's figure out what that is. That's 25 times 16 plus 18 times 0. 25 times 16 equals 400, plus 0 is going to be 400. So you're going to get 400 packets. 25 times 16 plus 18 times 12. So 25 packets for all 16 skilled workers, 18 packets for all 12. 25 times 16 plus 18 times 12. That's going to give me 616 packets. So now the question is that enough, or can I get more from here? 25 times 8 skilled workers plus 18 times 24 students. 25 times 8 plus 18 times 24, and that is 632. So Brad needs 8. He does not have to have all 16. He needs 8 skilled workers and 24 students. Now I've answered the question, but I want to go back and mention one thing. All right, I mentioned this at the beginning. We can now figure out how many packets they're going to produce, but there's one piece of information that we don't have. And the piece of information is they're getting paid for the day, but we don't know how many hours they're working in a day. The problem doesn't tell me that. The problem does not ask how many packets you're going to make. All right? This tells me how many packets you're going to make in an hour. I just don't know how many, because it's 25 packets for an hour for the skilled, 18 for an hour. So this would be, these numbers would be total for 1 hour. I don't know how many hours they're going to work. So I know people have asked that in the past, but like, well, how many packets are they going to make? I don't have enough information to answer that question. And that question was not in the original problem. Okay? I'd have to have more information for that. So don't worry about it. All right, we'll see you in the next video.